Hello everyone. In the previous video we learnt about the circle, its definition, the definition of its parts and some of the terms related to it. In this video we will be learning about the chord and its properties. We have already learnt about the chord. What a chord is? A chord is a line joining any 2 points on the circumference of a circle. Here the first property we have, if any two arcs in a circle are congruent or equal, then their corresponding chords are also equal. Now we will learn how to prove this property or theorem. See, for any of the theorem, what we need? First we need a diagram. A diagram is drawn here with center O, a circle with the radius r, that is a circle COR, means center of that is O and radius is r. Two arcs have been given here, that is AB and CD, which are congruent or equal to each other. After the diagram, what we need? We have four elements in the theorem. The first one is given. In that we write what is given to us. Then to prove what is to be proved. Third is construction if required. And the fourth one is proof, main part of the proof. So here in this particular theorem we write the given part. Given a circle COR in which two arcs AB and CD which are equal to each other. To prove, what is to be proved? Chord AB and chord CD are also equal. They are corresponding chords to these arcs. So we write here chords AB equal to CD. This is to be proved. There is no particular construction required in this particular problem. So we go for the proof. In the proof, what we do? We have been given that arc AB is equal to arc CD. And we have learnt that any two arcs are equal if their degree measures are equal. It means here the degree measure of AB is angle AOB and degree measure of CD is angle COD. Will they be equal or not? Yes, suppose they are theta each. Now we can go to these two triangles. In triangle AOB and triangle COD. What we find? OA is equal to OC. And OB is equal to OD. Why? Because both are the radii of the same circle. Then angle AOB is equal to angle COD, that we have just now proved. Each is theta and we can write proved. What we find? Two sides are equal and their bounded angles are equal. It means by SAS congruence property they are congruent. So we can write therefore triangle AOB is congruent to triangle COD. By what? By SAS congruence. And if two triangles are congruent, their corresponding parts are equal. It means we can say that AB is equal to CD. They are the corresponding parts in these two. And that's what we have to prove. So we could learn the proof here that if any two arcs of a circle are equal or congruent, then their corresponding chords are also equal. If we go to the converse of the statement what we had just now in first. Converse means what? What was given in that we will be proving here, and what was to be proved that will be given here. So the converse says if two chords in a circle are equal, then their corresponding arcs are also equal. Or we can say equal chords in a circle cut equal arcs. The diagram here, a circle COR, O means the center of it, R means the radius of it. Two chords AB and CD are given to us. So we are writing given a circle COR in which AB is equal to CD, that is chords AB and CD are equal. To prove arc AB is equal to arc CD, that is what we have to prove. And there is no particular construction required in this also, so we go for the proof. Now we can take here triangle AOB and triangle COD in first. So we write in triangle AOB and triangle COD. What we find? OA is equal to OC. OB is equal to OD. In both we are finding they are equal to the radius of the circle. And we have been given that AB is equal to CD. This is given to us. Do we find all the three sides of this are equal to all the three sides of it? It means by SSS congruence the triangles are congruent. It means triangle AOB is congruent to triangle COD by SSS congruence. And if they are congruent, corresponding parts are equal. It means we can say angle AOB is equal to angle COD. Suppose each is theta. Here I have already written here theta. By what they are equal? By CP, CT, corresponding parts of congruent triangles. And what is angle AOB? This is the measure of arc AB. So we can write this implies that measure of arc AB, COD, this is measure of arc CD is equal to measure of arc CD. And the measure of two arcs are equal, then the arcs are equal or congruent. It means AB arc is equal to CD arc. And that's what we have to prove. So here we have proved that if any two chords in a circle are equal, their corresponding arcs are also equal. Next is the converse of this theorem. Converse means I have already told you. So here what we have? The chords which subtend equal angles at the center of a circle, they are equal. Draw the diagram. The same type of diagram. Two chords AB and CD subtending equal angles AOB and COD. Suppose each angle is theta. We have to prove that these two chords are equal. So we write given a circle COR whose center is O and radius is R, in which chords AB and CD are such that the angle AOB is equal to angle COD. We can also write here theta, let. We have to prove that AB is equal to CD. Here also no construction is required, so we go to the proof. In proof we take the same two triangles here. In triangle AOB and triangle COD, OA is equal to OC, OB is equal to OD, as these all are the radius of the same circle equal to R. And we have been given that angle AOB is equal to angle COD, that is theta, we have been given here. So what we find? Two sides and the angles subtended by them are equal. Therefore the triangles are congruent by SAS congruence. So we can write therefore triangle AOB is congruent to triangle COD by SAS congruence. And if they are congruent, corresponding parts are equal. It means AB is equal to CD, and that's what we have to prove, hence proved. So we could prove the converse also, that the chords which subtend equal angles at the center of a circle, they are equal in length. The next theorem is the perpendicular drawn from the center of a circle to a chord bisects the chord. So here we have a circle COR, the radius of this is R, center is O. There is a chord AB given in this, and OC is the perpendicular drawn from the center O to AB. We have to prove that OC bisects AB. So we write here, given a circle COR, a chord AB, and OC is perpendicular to AB. What is to be proved? That OC bisects AB. It means AC is equal to BC. Or we can say C is the midpoint of AB. Now we need a construction in this. What is that? Join OA and OB. We have written here construction, join OA and OB. Coming to the proof. In this particular theorem, we will take these two triangles OCA and OCB. In triangle OCA and triangle OCB, we have OA is equal to OB. That is because the radius of the same circle. OC is equal to OC. That is the common side to both the triangles. And angle OCA is equal to angle OCB. Each is 90 degree. Why? Because OC is perpendicular to AB. So these two angles will be 90 degree each. Do we find that these are two right angle triangles? These are the hypotenuse of both and one of the side. So can we say that they are congruent by RHS congruence? Yes. Therefore, triangle OCA is congruent to triangle OCB by RHS congruence. And if they are congruent, corresponding parts are to be equal. It means we can say AC is equal to BC by CP CT. That is corresponding parts of congruent triangles. And this is what we have to prove. And so we could prove the theorem that the perpendicular drawn from the center of a circle to a chord bisects it. The converse of this theorem is that if we join the midpoint of a chord to the center of a circle, then this line is perpendicular to the chord. So we can say that the line joining the midpoint of a chord to the center is perpendicular to the chord. The diagram is drawn here. We have a circle COR, a chord AB, and C is the midpoint of AB. It means AC is equal to BC. This is given to us. What is to be proved? That OC is perpendicular to AB. It means angle OCA and OCB are 90 degree each. Now here also we need a construction, that is join OA and OB. And then we go to the proof. For proof, again we are going in the same triangles OCA and OCB. So we write in triangle OCA and triangle OCB. OA is equal to OB, that is the radius of the same circle. OC is equal to OC, that is common side to both. And AC is equal to BC. This is what we have been given, that C is the midpoint. So we find that all the three sides of this triangle are equal to all the three sides of it. And therefore we can write triangle OCA is congruent to triangle OCB by SSS congruence. And if they are congruent, we can say that angle OCA and OCB, suppose we write this as 1 and this as 2. We can write therefore angle 1 is equal to angle 2 by CPCT. But we can also see that angle 1 plus angle 2 is equal to 180 degree. Why? Because they are forming a linear pair. This is a linear pair. Since ACB is a straight line. And if the sum of them is 180 and both are equal, suppose we write this as equation number 1 and this is 2. What we get from 1 and 2? That angle 1 is equal to angle 2 is equal to 90 degree. And if they are both 90 degree, then we can say that OC is perpendicular to AB, and this is what we have to prove. So this is the way we can prove the converse, that the line joining the midpoint of a chord to the center of the circle is perpendicular to the chord. The next theorem is equal chords are equidistant from the center of a circle. So here we have a circle COR. O is the center, R is the radius. In this, two chords AB and CD which are equal to each other, and we have to prove that these two are equidistant from the center, means they are at the equal distance from the center. So there are two perpendiculars drawn from O to these two, that is OE on AB and OF on CD. So what is given to us? A circle COR in which two chords AB and CD are equal to each other, AB equal to CD. Then we have to prove that OE is equal to OF, OE is perpendicular to AB and OF is perpendicular to CD. Now here we need a construction, and that is join OB and OD. Now coming to the proof. We know that if we draw a perpendicular from the center to a chord, it bisects the chord. So we can write, since OE is perpendicular to AB and OF is perpendicular to CD, this implies that AE is equal to BE and CF is equal to DF. And this will be equal to half of AB. This will be equal to half of CD. Now we have been given that AB is equal to CD. It means half of AB also will be equal to half of CD or not. It means we can say that BE is equal to DF. We can write this as 1. And now we go in these two triangles, in triangle BEO and triangle DFO. What we find? OB is equal to OD. Why? Because this is the radius of the same circle. BE is equal to DF. We have already proved in 1. And then we have angle BEO is equal to angle DFO because each is 90 degree. That is because OE is perpendicular to AB and OF is perpendicular to CD. Do we find that these are two right angle triangles? These are the hypotenuse of them, and this is one of the side. So by RHS they are congruent. So we get, therefore, triangle BEO is congruent to triangle DFO, that is by RHS congruence. And if they are congruent, corresponding parts are equal, it means OE is equal to OF. This implies that OE is equal to OF, and this is what we had to prove. So we could prove here that equal chords are at equal distance from the center. The converse of this theorem is that if we have any two chords which are at equal distance from the center of a circle, then the chords are equal. How to prove this? The The diagram is here. We have drawn a circle with center O and radius R. In this, two chords AB and CD are given such that the distance of them from the center, that is OE and OF, are equal, where OE and OF are perpendiculars drawn from the center to the chords. So what is given? A circle COR in which chords AB and CD such that OE is equal to OF, where OE is perpendicular to AB and OF is perpendicular to CD. What we have to prove? AB is equal to CD, the chords are equal. The construction, we need a construction in this, join OB and OD. Now comes the proof. We know if we draw a perpendicular from the center to a chord that bisects the chord. So we can write, since OE is perpendicular to AB and OF is perpendicular to CD, this implies that AE is equal to BE is equal to half of AB and CF is equal to DF is equal to half of CD. Now we take these two triangles. In triangle BEO and triangle DFO, what we find? OB is equal to OD, that is because the radius of same circle R. OE is equal to OF. This is given to us. And angle BEO is equal to angle DFO. Both are 90 degree. This is also given to us. Why? Because the perpendiculars have been drawn to the chords. Here we find that these are two right angle triangles, these are hypotenuse of them and these are one of the sides. It means by RHS they are congruent, and therefore triangle BEO is congruent to triangle DFO by RHS congruence. And if they are congruent, their corresponding parts are equal. It means this BE will be equal to DF. This implies that BE is equal to DF by CPCT, corresponding parts of congruent triangles. We have seen here that BE is half of AB and CF and DF both are half of CD. Can we write here that BE, that is half of AB, is equal to DF, that is half of CD? If half of AB and half of CD are equal, this implies that AB is equal to CD, and this is what we had to prove, hence proved. So here we could prove that if the chords are at equal distance from the center, the chords are equal in length. The next theorem we can have, the chord near to the center of a circle is larger. The converse of it is the larger chord is near to the center of the circle. Of course, these two theorems can be proved, but the only thing is we need the inequalities in that. And the logical proof of this can be given that if we draw a circle like this with center O and draw a diameter in it, AB is the diameter, and we have drawn two chords CD and EF. We are finding that CD is larger than EF, which is nearer to the diameter or nearer to the center. EF is away from this. It means we can understand these theorems logically, that the larger chord is near to the center or the chord which is near to the center is larger. In the next video, we will be learning about the theorems on congruent circles. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.